So you have to open this.
So this is just nitration,
Yeah.
but using that tube?
Yeah.
Okay.
So you have to make these things like a funnel, but you have to make such way so that it can go through this. So start with any corner, okay? Like this, okay? And then try to make it
Funnel.
smaller here so that it can go all the way inside.
Okay.
Like this tail should cross this line.
Okay.
So that whatever you add, everything it can go.
Is it too narrow, those other funnels over there?
Yeah, and also you have to have a hole. You can see that hole, right?
Yeah. Yep.
So that you should have that hole, and so that the solid can go inside. And now you can measure your solid, and you will pour here. This is weighing paper, so you will pour it here, and it will go directly there. Remember one thing: if you have the solid, big chunk, so in that case you have to break the big chunk solid so that it can go through that hole. Okay. So now I'm going to start measuring the solids I need.
Yep.
There are 3 solids will go there.
Yep.
One is my starting material, another is ferric ammonium nitrate, and another is copper acetate. All those 3 together I will add it there, and then I will add the solvent 1,2-dichloroethane. In short it is called DCE. And then I will close this tube, and then I will start reaction. In that time I'll show how I will
When you start it?
Okay, so this is your solid. Hold it like this. Yeah, there is no solid inside.
Pretty.
Yeah, this is ferric ammonium nitrate and copper acetate. So we are going to use solid inside it. So make this way and then hold it this way and pour it directly. So we don't have any more solid to add. So just this way, and then now we are going to use solvent. But before arranging the solvent, you can just close it because those can be hygroscopic or can absorb water. So now I'm bringing the solvent, and I will add the solvent, and I will do the big S with this tube. And after that I will close it, and then I will start reaction. Turning on the gas. So gas is on. Make sure that because this solvent is like sealed solvent, so you have to dispense the solvent under argon. So now I'm gonna take 10 milliliter of solvent, and before taking the solvent, make sure that you open this one, otherwise it will be tough to add and open this once you take out the solvent. So take out the solvent. Flash it.
Oh, you're not keeping this under the gas also? The actual tube?
Yeah.
'Cause I saw earlier you were also leaving it exposed. not too big of a deal if the solid is exposed for a little.
Yeah, I can do the
Gas.
gas, yes.
And we can do that here, right? Or is it strong enough for vacuum?
Yeah, we can do it here.
Yeah, the vacuum in our lab, this one here is relatively weak compared to that one over there.
So add the solvent with the wall so that if any solid is stuck in the wall, it can be washed out. Now I'm gonna close it quickly. And I'm going to. Okay, let's do the back one there because there is no needle option. Let's go.
Did you just put it under vacuum for like a second?
Yeah. Now I'll
Yes.
put a little gas.
Yeah. Oh, be careful, like always.
Yeah.
The oil doesn't explode.
Yeah, now it looks like under gas. So now you can close it all the way down. Once it is closed, close it. It's closed. Take out this tube. So now it is closed and everything I did, whatever I needed.
Yeah.
So I'm going to put it in a well bath and attached with the clamp, and I'm gonna start stirring and heating. But before it start heating, I need to use a shield here.
Protection.
So I'm going to put this shield.
This is always my least favorite step.
Yep.
It's so annoying to deal with this. It takes up your space too. But it is a necessary evil. I guess you do a little bit.
Yeah.
Look at this man's painful struggle thanks to the shield. Ah, beautiful.
Okay. So make sure that near the reaction area there is no tube and other things. Although our hood looks like so messy because we are doing multiple work together, so it may not be look like this, but it should be like clutter free as much as possible and all kind of like rubber tubing away from the heating source. So this is very important because otherwise it can be like fire hazard.
Oh yes. Tie things together with those white fuzzy arts and crafts wires you have.
Yeah,
Make sure the
so,
tubes don't melt by the glass.
yeah. So now everything is fine. Just we'll continue this reaction for 12 to 14 hours.
Oh, we're reducing it. We're reducing the amount of time for this one.
Yeah, there is.
That's that's
Yeah,
enough.
normally there is enough for this.
Okay.
Okay, so once your reaction setup is done, make sure that you clean up your area, like whatever the things you used, just
And then just keep an eye on the
keep an eye
temperature.
on the temperature.
Make sure your probe is in. Don't make that mistake.
Yeah, don't make the mistake. Like if you use reaction probe, like heating probe, so make sure that your heating probe is in the well. Otherwise, the heating source will not working, and your reaction will be messed up. Thank you for watching us, and hopefully it will help you for setting the reaction in a sealed tube or like Schlenk tube reaction. And if you like our video, then subscribe the channel to keep the update.
Subscribe, leave a like, please. Share it with all your friends. Bye bye.